Hello, everybody. Welcome to today's video lecture, and we are covering the integumentary system. So let's go ahead and begin. Now, integumentary system is the first body system we cover in this class. I want to remind you that if you take a whole organism and you start putting it or breaking it apart, then you get to different levels of organizations. The smallest level of organization is chemical. So from atoms and molecules, we have then organelles. From organelles, we make cells. Cells make tissues. Tissues make organs. And organs make organ systems. So when we're talking about an integumentary system, it's a collection of organs that perform specific functions. Now, what is the function of integumentary system? Well, it covers the surface of your body. So it protects underlying organs. For example, tissue from physical trauma. So it will protect your muscles, your bones. It acts as a barrier, preventing pathogens. Pathogens are infecting agents to entry your body, like bacteria, viruses, fungus. It regulates your body temperature. When your body temperature goes up, you can notice that your skin became pink, or it's what we call flushing. And when your skin became pink, you radiate this extra heat away from your skin and you cool yourself down. Or when you get cold, your skin became pale. Now, why your skin became pale? Because those blood vessels constrict and blood flow away from your skin. So you keep that heat inside your body. So you don't lose, you don't radiate a heat from your skin. And by doing that, you keep your body warm. Another function is synthesize chemicals. Your skin secretes sweat, for example, or oil. Also, your skin allows you to be aware of your surroundings, like sense of touch. In your skin, you have receptors for temperature, for example. So if you touch something, you know, is it hot or cold? You can also feel texture of the material. You can feel pressure, you can feel touch. So all of this because your skin has a sensory receptors that allow you to be aware of what surrounds you. Your skin is also waterproof. Skin has protein called keratin, and it's prevent dehydration of your body. So it prevent you from losing water, and it's also prevent you from getting extra water inside your body. Right, so those are function of the skin: protection and of underlying organs, barrier, body temperature regulation, synthesis of chemicals. Here you're giving sweat and oil, but your skin also synthesizes precursor of vitamin D. So that's another chemical that your skin synthesizes. Give you awareness of surroundings and prevents you from dehydration. Now, if you look at structure of the skin, you can see that skin is actually made of 3 layers. So the most superficial layer, so it's the layer on the top, is epidermis. Middle layer is dermis. And then we have what it's called subcutaneous tissue or subcutaneous fat, or another name is hypodermis. Right, so epidermis is a superficial region, consists of epithelial tissue and is avascular. Avascular means it doesn't have blood vessels. Dermis, it underlies epidermis. It mostly fibrous connective tissue, and it's vascular, so that's where you have your blood vessels. And hypodermis not part of skin, but shares some functions. Mostly adipose tissue that absorbs shock and insulates. Adipose tissue means fat tissue. So over here, you can see a structure of the skin. And again, we can see that we have epidermis, superficial layer. Then we have dermis, and dermis is made of two parts, papillary layer and reticular layer, and hypodermis. And again, hypodermis is not part of the skin, but it shares some functions. Also, if you notice, you don't have many structures inside epidermis, but you have lots of different parts and structures inside dermis. So over here, we can see, for example, a sweat gland. So here's a sweat gland, and it has a duct. So this is called secretory unit, where you make sweat and then you deposit it through the duct on the surface of the skin. Now, next structure right here, this is a muscle called erector pili muscle. And when this muscle contracts, it allows this hair to stand up. It's also cause goosebumps on our skin when we are cold. Now, this gland over here is oil gland or sebaceous gland. You also see the hair follicle, and hair follicle is the organ that makes your hair. So inside this hair follicle, you have hair root. Also, you can see lots of blood vessels. So those are more deep blood vessels, but you also have here papillary loops. But if you notice, all blood vessels located in dermis, not in epidermis. And we have some nervous structure over here. So we have these nerves, free nerving. We have the special receptors, like touch receptors. We have nerves that innervate the hair follicle, right? Okay, so so I'm gonna remove all of this drawings that I had over here, so we can look again to this picture and see the structure of the skin. Also, what I forgot to mention, you have a hair shaft over here. This is the part of the hair that is visible, so it's above the surface of skin. Okay, so epidermis consists mostly of keratinized stratified squamous epithelium. Stratified, the word stratified means many layers, so we have many layers of cells. And squamous means that cells on the surface are flat. And keratinized tell us that this upper part of your skin cells are dead, right? So this dead on the surface, we have dead skin. So this is a type of epithelium that made of many layers of tightly packed flat cells with protein keratin on the surface of the skin. Now, cell of epidermis include keratinocytes. So most of the cells are keratinocytes that produce keratin, protein that gives skin its protective properties. Millions of those keratinocytes slow off every day. So you lose millions of those cells every day. By the time you lose them, they're already dead cells. But we also have other cells in epidermis. We have melanocytes. Those produce pigment melanin. Melanin is transferred to keratinocytes, where they protect from UV damage. So melanocytes make melanin. But then this melanin is picked up by those keratinocytes. Now, melanin is deposited around the nucleus and protect nucleus of keratinocytes from UV radiation. Another type of cells that we have in epidermis are tactile or Merkel cells. Those are sensory receptors that sense touch. Now, what is this UV rays? UV stand for ultraviolet light that could lead to cancer and a loosening of skin. So we have two types of UV radiation, UVA, long waves, and UVB, short waves. Melanin is a natural protective measure by your body against UV rays. Some daily exposure to UV rays is actually good because it converts cholesterol to vitamin D. Protection against UV rays include sunblock, sunscreen that contain SPF or sun protection factors. So if you see on a sunscreen SPF 15, what does it mean? It means that it takes you 15 times longer to get burned. So if you, for example, burn in 20 minutes, then SPF protection, SPF 15 protection would give you 5 hours of protection. So instead of 20 minutes, you need now 5 hours to get sunburn. And of course, remember that you need to apply sunblock several times. If you, for example, go to the beach and you swim in the water, even some sunblock water resistant, but still it's a good practice to reapply your sunblock maybe every 2 or 3 hours. Okay, so when we're looking at epidermis, and I want to remind you that epidermis is a superficial, so top layer of your skin. It's actually divided into several layers. We call those layers strata. So if we start from deep to superficial, so we go from a deep part of epidermis to the surface of your skin. Now, the deepest one is stratum basal. Those are actually dividing cells, and they are the cells that create new skin cells. After that, you have stratum spinosum. In stratum spinosum cells, keratinocytes, they connected to each other through structure called desmosomes. So all skin to withstand tension and pulling. So desmosome allow your skin cells to be connected, and at the same time, it give it a little bit of give. So when you pull on your skin, you can stretch it without tearing it apart. Next, and again, we're moving to the surface. Next stratum is stratum granulosum. Cells starts to accumulate keratin fibers. Next is stratum lucidum. This one found only in thick skin. And thick skin you have only in your hands and your feet, your palm of the hands, not this back side, not the dorsal, not the back side of your skin, but your palm and the sole of your feet. So that's where you have your thick skin and you have stratum lucidum. Rest of your body, skin doesn't have this stratum. And the most superficial layer called stratum corneum, 20 to 30 layers of dead keratinocytes. And it acts as barrier to prevent water loss. It's also prevent pathogens to enter your body, protects you from some mechanical trauma of the skin. Right, so let's look at histology. And histology means we will look at the tissue over here. Well, right now we're looking at skin, but we're only looking at epidermis. And you can see stratum corneum, the thickest one, 20, 30 layers. That's on the surface of your skin, and those cells are dead. Stratum granulosum, those are also cells that are dying. Stratum spinosum, and the only cells that can divide found in a stratum basal. So it's one layer of stem cells. So if you look at the picture, instead of the histology slide, you can see those dead keratinocytes on the top, then keratinocytes that accumulate those granules of keratin, stratum spinosum, stratum basal, but you also can see a dendritic cell over here. It's for immunity, tactile cell for touch, and you can see melanocyte over here. Now remember that melanocytes make melanin, but if you would only have melanin over here in melanocytes, you would not have much of protection of your skin. That's why this melanin is deposited into your keratinocytes. So your keratinocytes accumulate this melanin, and it protects nucleus of keratinocytes from UV radiation, right? Okay, so let me again remove all this drawings so we can move to the next slide. Now, dermis. Dermis is under epidermis. In anatomy, we say it's deep. So epidermis is superficial, dermis is deep. It's a strong, flexible connective tissue. It contains nerves, blood vessels, and lymphatic vessels, contains epidermal hair follicles, oil gland, sweat glands, and it has 2 layers. Now, remember, epidermis has 4 or 5 layers. Now, in thick skin, 5 layers. In the rest of your skin, 4 layers. When the dermis has only 2 layers, papillary layer, a superficial layer, about 20%, made of areola connective tissue, interlacing collagen and elastic fibers also found in that layer. And another 80% of your skin is a reticular layer. It consists of dense connective tissue that also has elastic fibers, also has collagen, and because of it has a good amount of elastic fibers, it has recoil properties. Collagen fibers provide strength and resiliency. So it binds water, keeping skin hydrated. So on this slide, you can see epidermis. And if you notice here, so all this kind of like darker tissue, right? So from here all the way to the up, that's epidermis. And the rest is dermis. But you see, dermis has this, what it's called papillae. So those called papillae of dermis. And that's why the layer is called papillary layer. So this is where your papillary layer is. And so it's about a little bit below those papillae, and the rest is reticular layer. And this layer is made of different tissue. So areolar connective tissue, papillary layer, and dense irregular connective tissue, reticular layer. Oh, see what happens if I don't remove those drawings. All right, clinical application, homeostatic imbalance. So extreme stretch of skin can cause dermal tears, leaving silvery white scars, what we call stretch marks. Now, how stretch marks are formed? So when skin is stretched, it has the ability to recoil back and without any damage to the skin. But when the stretch is very extensive, then we have some tears in the collagen fibers. And when we have tears in collagen and elastic, your skin heals by forming those scar tissue. That's what stretch marks are. When the skin is just stretched so much that it cannot recoil back, and it heals by forming scar tissue. Another homeostatic imbalances of the skin include blisters. Those are acute short-term traumas to skin that can cause those blisters. It's a fluid-filled pockets that separate epidermal and dermal layers. So we all had blisters in our life, right? So when you have a lot of stress on your skin, especially abrasion, you can separate epidermis and dermis, and that's where you have those fluid-filled pockets called blisters. Okay, so we already know that skin is made of epidermis and dermis, and in a dermis you will find what is called appendages of the skin. Appendages include nails, hair follicles, sweat glands, and oil glands. And we have 2 types of sweat glands, eccrine and epicrine. Now, eccrine are more numerous glands. So most of your glands are eccrine. And eccrine glands produce a sweat that is 90% water. And this is for thermoregulation. Apocrine sweat glands found in your armpits or near your genitals and near your anus, in anogenital region. And those produce sebum. So it's produced sweat that has not just, it's not that watery. It has some oily substance in it. And those apocrine glands are not for thermoregulation, but for odor. So that's give you your body odor. An oil gland produce oil. So we're gonna look at the nail and hair on this slide. So nails are protective covering. Nail grows from a nail root that is a nail matrix. And nail root is protected by skin fold called cuticle. So if you look at this picture, so this is called the body of the nail, right? And this is your cuticle, that is a fold of the skin. And this part of the nail, this is where you have cells that can divide, and multiply, divide, so and synthesize keratin, because nail, the same as your hair, is made of keratin. It just this keratin is more durable, so it's a stronger protein compared to your hair. In a hair, you have a hair follicle. So hair follicle is actually made of epithelial tissue. So you see how this purple stuff continues to make your hair follicle over here. So it's a structure that produces hair. Hair matrix, so you will find the hair matrix in this area, and it's also the same as nail matrix, the same as hair matrix. This is where you have cells that can divide. And this is where either hair growth, if it's hair matrix, or nail growth, if it's nail matrix. And hair shaft, it's location where hair comes out of the skin. So that's going to be hair shaft. Okay, so let's see if I can remove all my drawings here. So we can move to the next slide. Glands, oil glands. Okay. Produce oil connected to hair root, and function is lubrication. So if you know, people have what is called white heads. This is where sebum, and sebum is that oil that oil gland produce. Sebum secretion is blocked. Black heads happen when these white heads are oxidized. So when this sebum reacts with oxygen, it's oxidized and turned into a black color. Acne is inflammation of the sebaceous gland. And this is our sweat glands. As we already said, we have two types of sweat glands. Eccrine, sweat produced to cool body, a limited odor, mostly water, most numerous through the body. And apocrine, sweat produced during stress, excitement, smelly sweat, yellow color, presence of proteins, and found in armpit, groin, and nipples. So if you look at this picture over here, you can see that's a eccrine sweat gland. So you see it's not that deep, and it secretes sweat on the surface of your skin. When apocrine gland found deeper in your skin, and it secrete sweat in a hair shaft. Right, so one is for thermoregulation, and another is to produce a body odor. Okay, skin cancers or carcinoma. We have two types of carcinoma: basal cell carcinoma and squamous cell carcinoma. Basal cell carcinoma is the least dangerous and most common. Now, what is the difference between just a regular tumor and cancer? Well, cancer metastasizes. That means it's spread to other parts of body. That's why cancer is dangerous. If it's benign tumor, cells might divide, form a tumor, but if it doesn't spread to other body parts, then it's not cancer. Or, of course, benign tumor can then become cancerous. So basal cell carcinoma, least malignant, most common. When we have basal cells, remember we have the stratum basal, so it's the deepest layer of epidermis. And it looked like a small dome-shaped nodules, usually on sun-exposed area, easily removed with outpatient procedure. Squamous cell carcinoma, small, red, scaly, usually present in scalp, low lip, ears. It has a rapid growth, can metastasize if not removed, and good chance of survival with radiation and cervical removal. Okay. Another type of skin cancer is melanoma. It's a cancer of melanocytes. It has brown color, irregular shape, highly metastatic, starts randomly. Early detection is essential for survival and does not respond well to chemotherapy. So when we determine melanoma, we use what is called ABCD rule. Now, A stands for asymmetry. So you can see a normal mole and melanoma. Asymmetry means when the half of the mole does not match the other half. B stands for border, when the border or edges of a mole are ragged or irregular. Color, when the color of a mole varies through the mole, so it's not the same color, it has a darker parts, lighter parts, and diameter, if the mole's diameter is larger than a pencil eraser. Then so if you have a suspicious mole and it presents you with all these four signs, asymmetry, border, color, and diameter, then you need to talk to your doctor about it. It doesn't necessarily mean it's melanoma, but it's something that the dermatologist should closely monitor, maybe take biopsy, and just look at it and see if it's something that might possibly be dangerous or not. Burns. Burn is tissue damage. It can be a result of heat, electricity, or radiation. In the case of severe burn, basal cell is destroyed and skin lose the ability to regenerate new skin. And if we have like very superficial burn, and if you have still those stem cells in the stratum basal, they can regenerate and your damaged skin will be replaced. But if cells of stratum basal are damaged, then you don't have any cells to produce epidermis. Then patient requires skin graft. We have two types of graft: autografting, and auto means self, when skin transplant from one body region to another body region of the same person's body, and allografting. Allo means different, when skin transplanted from another individual. We classify burns into degrees. First degree burn, only epidermal damage. Localized redness, edema, swelling, and pain. No medication needed, it heals on its own. Second degree burn, we have epidermal and upper dermal damage. Blister appears, and it also can heal on its own. First and the second degree burns are referred to as partial thickness burns because only the epidermis and upper dermis are involved. So in this picture, you can see a first and a second degree burn, and the difference is the first degree is, yes, it's swell, it's painful, it's red, but it doesn't have blisters. When on a second degree burn, you can see blister over here on the hand. Now, the third degree burn, entire thickness of skin involved, referred to as full thickness burns. Skin color turns gray, white, cherry red, or blackened. No edema is seen and area is not painful because nerve endings are destroyed. A skin grafting usually necessary. So it's interesting if you look over here, both first and second degree has pain. Patient has pain. When it's third degree, there is no initial pain because nerves are just burned and you have no receptors and no nerves that would send the signal of pain to your brain. There is also a fourth degree burn. This is injury that is not limited to skin. So it will involve bones, muscles, tendons, and in many cases may lead to amputation of the affected body part. So in some books, you will see classification only first, second, and third degree, a burn of the skin. Why? Because the fourth degree, it's not limited to a skin, it's affect other organs as well. So on this diagram, you see only first, second, and third degree burn of the skin. So first, only involved the upper part. So you see that this part over here, this, by the way, is healthy skin. So the burn only involves epidermis. The burn goes below epidermis, but not always through the dermis. And this is, you have epidermis and entire dermis destroy. So that's going to be full thickness or third degree burn. Now, if we have a patient that has a skin burn, the immediate threat is actually dehydration. So patient require fluid resuscitation. And to know exactly how much fluid this patient need, we need to estimate body surface area that is affected by a burn. Right, so they use what is called rule of 9 because the body divided into 9%, surface area divided into 9%, or half of 9, or 18, that is double this number 9. You have so neck is 1% of the body, then front of the body is 18%, and back of the body is 18%. Front and back of the arms is 9%. Front and back of the legs is 18%. Right, so that's how you estimate the extent and severity of burns using the rule of 9s. Now, you say like, okay, where those 9s are? Well, the 9s here is because 18 is 9 times 2, right? And 18 is 9 times 2. So you pretty much can say that the front is 9 times 2, back is 9 times 2, legs are 9 anterior and 9 posterior. So this one is 9 and back is 9. And for the arms, it's actually 4.5 and back is 4.5. So total is 9%. Oops. Okay. So and again, we need to estimate the surface of body area affected by burn to calculate the amount of fluid this patient needs. So burns are considered critical if more than 25% of body has second degree burns, more than 10% of body has third degree burns, face, hands, or feet bear third degree burns. Treatment includes debridement. Debridement means removal of burnt skin, antibiotics to prevent infections, temporary covering, and sometimes require skin grafts if skin damage to the point where it cannot recover on its own. Bed sores, or what is called decubitus ulcers. ACA is bed sores or pressure ulcers, injury to skin and tissue as a result of extended pressure on one area of skin. Common area, hips, ankles, and heels. Treatments include antibiotic to prevent infection and removal of damaged tissues. Okay, I think that's it. This is the last slide. So just very quick review. We talk about function of integumentary system. We talk about layers of skin. Structures are found in dermis. We talk about cells that make epidermis, the importance of sunblock to prevent damage of DNA of those keratinocytes by UV radiation. We talk about 5 layers of epidermis, about 2 layers of dermis, and we cover accessory organs such as nail, hair, oil, sweat glands. And at the end of this chapter, we talk about skin cancer, skin burns, classification of burns, and we ended up with a rule of 9 and bed sores. Okay, so thank you for watching, and I hope it was helpful.